If you have a look at the first one, all we need to do is reflect in the line y equals x. You happy the line y equals x looks like this? So on the left-hand side, I've drawn I and j as they stand, so 1, 0 and 0, 1, and I've got the identity matrix there. What happens if I reflect them in the line y equals x? Where does I end up? What's the vector? I is here. Where does it end up afterwards? In the line y equals x. So y equals x is this line. Reflect it over. It was here. Reflect it. It comes up. Literally flips over up to where? 0, 0, 1. Perfect.
I didn't get it back. But if we give x 0, then I will be 0, y will be 0.
So the line y equals x is this line at 45 degrees to the axis.
Yeah.
Yeah. So if you reflect this arrow, just the blue one, if you reflect it over, it's going to end up over here, isn't it? Just like a mirror line. Yeah? And where's j going to end up?
Oh, well, then 1.
Yeah, 1, 0. Does that make sense?
Yeah, it makes sense.
Yeah, so my transformation matrix, which will correspond to a reflection of the line y equals x, will be 0, 1, 1, 0. Is that okay?
Yes.
Good, okay. What about rotation 90 degrees clockwise about the origin? So clockwise in that direction. Okay, where's I going to end up? 0. It's in that direction, so it's 0, negative 1, yeah?
0 minus 1.
0, negative 1. And where's j going to end up?
1 to 0.
1, 0, perfect. So that is the transformation matrix that corresponds to rotation 90 degrees clockwise about the origin. Is that okay? Mm-hmm. Okay. Now here we've got an enlargement. So basically just means make bigger. And it's by a scale factor of 3 in every single direction. Okay? So we want enlargement by a scale factor of 3 about the origin. Where's I going to end up?
3.
3, 0.
2, 0, yeah.
Yeah, absolutely. So it's going to be 3 times as long. Where's j going to end up?
0, 3.
Yeah, 3 times as big in that direction. Is that okay? Yep, good. Okay, what about stretch in the y direction? It's got 2 going on here. Stretch in the y direction with a scale factor of 2. So it's just being stretched in that direction and the x-axis is staying the same. Okay? So if we stretch in the y direction with a scale factor of 2, where's j going to end up? And where's I going to end up? So where's I going to end up first?
1, 0.
Yeah, it's still going to stay the same. Okay, so I is going to end up at 1, 0. Where's j going to end up though?
0, 2.
0, 2. Perfect. It's going to be twice as big because it's a scale factor of 2. Okay? Then we reflect this in the x-axis. So reflect this in the x-axis. So where's I going to end up?
0, 1.
Yeah, it's not going to change. Where's j going to end up?
2, 0.
Be careful. 0, 0, negative 2. Hang on, wait, that's the other way around. So I doesn't move. It's still 1, 0. And j ends up at 0, negative 2 instead. So this has 2 built into 1.
But then how the first one got changed to differently than
Yeah?
this?
Because this is different. This is a reflection in the line y equals x. Mm-hmm. This is a reflection in the x-axis. They're different things.
I see, I see.
Yeah? Have a look at question 5 for me. So question 5 is a bit weird. It's asking for a shear with a scale factor of 2 in the x direction such that the invariant line is the x-axis.
What's shear mean?
So shear basically means you're stretching it, but you're kind of pushing it at the same time. So here, this was a stretch in the y direction. In other words, it happens vertically upwards. If I shear something, it means I still pull it in that direction, but I kind of pull it off at an angle. Yeah? So instead of going in the same direction as the y, I kind of pull it off at an angle. So you can see here that I'm shearing it in the x direction. I'm shearing it in the x direction, which is in that direction, with a scale factor of 2, such that the invariant line is the x-axis. Okay? So I've literally got to pick up I've literally got to pick up j, so I is not going to move, okay, because it doesn't change. And I've literally just got to push it over, so it's now twice as far away as it was before. Okay? So if I come back to GeoGebra, because I think that's the best place to look, I should end up So if I just reset my, my basis vectors again. So I doesn't move, it's just J. And it corresponds to a shear, which is twice in this direction. So I should end up with something like that. Okay? So my transformation matrix is going to be 1, 0, 2, 1. Okay?
But how did we calculate it?
Because I knew from the description. So because the invariant line is the x-axis, it means anything on the x-axis doesn't change. Anything which is on the y-axis now gets changed, so it's twice as far away from where it was before, but it's in the x direction. Yeah, so it's literally like picking up and pulling it that way in the x direction. Okay? And you know, so I get something weird like that going on. Don't worry too much about shears. I won't ask about them in any exam. I just thought I'd put them in there to show you. Okay? So